Electrical wiring used in hard-wired smoke detector installations does have fire resistance rating requirements. The National Electrical Code, specifically Article 760.54 A1, mandates that wiring for smoke detectors adhere to Article 300. Article 334.NB stipulates that non-metallic sheaths cable, NMB, must be shielded from physical damage encompassing fire exposure. Thus, an NMB cable used for hardwired smoke detectors requires protection from fire using one of these methods. Firstly, installed inside a conduit. Secondly, run through a fire-rated enclosure. Thirdly, run through a protected area unlikely to experience fire exposure. Suitable fire-rated enclosures include metallic conduit, fire-rated raceways, and approved fire-rated boxes. Furthermore, Article 760.115 dictates that hardwired smoke detectors must connect to a dedicated branch circuit without additional loads. Article 760.116 mandates smoke detector connections to circuits not susceptible to overcurrent protection from fuses or circuit breakers, which could trip during a fire. To summarize, an NMB cable suits hardwired smoke detector installations provided it receives adequate fire protection through the aforementioned methods. Always refer to local building codes and consult a qualified electrician for specific requirements in your area. Considering the specifics of the NEC 2017 and its implications for fire safety in electrical installations, let's delve deeper into the reasoning behind these regulations. The core principle is to ensure the reliable operation of smoke detectors during a fire event, preventing failures due to compromised wiring. The NEC focus on protecting NMB cable stems from its vulnerability to fire damage. NMB cable, while suitable for many residential wiring applications, can melt or degrade when exposed to high temperatures, potentially disrupting the electrical circuit and rendering the smoke detector inoperable. To mitigate this risk, the NEC mandates physical protection through conduit, fire-rated enclosures, or location in areas with reduced fire risk. The choice of protection method depends on the specific installation environment and local code requirements. For instance, in exposed areas such as unfinished basements or attics, conduit offers a robust solution by encasing the wiring in a metallic or non-metallic sleeve, shielding it from physical damage and direct flame contact. Fire-rated enclosures, on the other hand, provide a more comprehensive level of protection, often incorporating intumescent materials that expand when exposed to heat, sealing off the enclosure and preventing fire from spreading to the wiring. When running NMB cable through protected areas, careful consideration must be given to the potential fire hazards in the vicinity. This might involve routing the cable away from heat sources, flammable materials, or areas prone to fire ignition. The NEC emphasis on dedicated branch circuits for smoke detectors is another critical safety measure. By isolating the smoke detector circuit from other electrical loads, the risk of overloading the circuit and tripping a breaker during a fire is minimized. Additionally, the prohibition of overcurrent protection devices that could trip during a fire ensures that the smoke detectors remain operational even if other electrical components fail. It is crucial to understand that fuses and circuit breakers are designed to protect electrical circuits from overloads and short circuits. However, in a fire situation, these devices may trip due to unrelated electrical faults, potentially disconnecting the smoke detectors from their power source. By eliminating the possibility of such disruptions, the NEC aims to maximize the reliability of smoke detection systems. The selection of appropriate wiring methods and protection techniques for smoke detector installations requires careful consideration of several factors, including the building's construction type, the presence of fire hazards, and local code requirements. Consulting with a qualified electrician is essential to ensure that the installation meets all applicable safety standards. A qualified electrician can assess the specific installation environment and recommend the most suitable wiring methods and protection techniques to safeguard the smoke detector circuit against fire damage. They can also verify that the installation complies with all relevant NEC provisions and local building codes. In addition to adhering to the NEC requirements, it is also important to follow the manufacturer's instructions for the smoke detectors and wiring components. The manufacturer's instructions may provide specific guidance on installation procedures, wiring connections, and testing protocols. Failure to follow these instructions can compromise the performance of the smoke detection system and potentially void the warranty. Regular testing and maintenance of smoke detectors are crucial for ensuring their continued functionality. Smoke detectors should be tested monthly by pressing the test button and verifying that the alarm sounds. Batteries should be replaced at least once a year, or more frequently if the detector indicates a low battery condition. It is also important to clean smoke detectors regularly to remove dust and debris that can interfere with their operation. Dust can accumulate in the sensing chamber of the detector, reducing its sensitivity to smoke. Cleaning can be done using a vacuum cleaner with a brush attachment, or by gently wiping the detector with a damp cloth. In summary, the NEC fire resistance requirements for smoke detector wiring are designed to protect the reliability of these life-saving devices during a fire event. By understanding and adhering to these requirements, building owners and electricians can help ensure that smoke detectors remain operational and provide early warning of a fire, giving occupants valuable time to escape. Remember that local codes may have additional or more stringent requirements, so always consult with local authorities and a qualified electrician to ensure compliance with all applicable regulations. Furthermore, the NEC addresses various types of wiring methods suitable for different applications, each with its own set of installation requirements and limitations. Understanding these wiring methods is crucial for selecting the appropriate wiring for smoke detector installations and ensuring compliance with the NEC. Some common wiring methods include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, flexible metal conduit, and non-metallic conduit. Each of these wiring methods offers different levels of protection against physical damage, fire, and other environmental factors. Rigid metal conduit, for example, provides the highest level of protection due to its thick walls and robust construction. It is typically used in industrial and commercial applications where wiring is exposed to harsh conditions. Electrical metallic tubing, on the other hand, is a lighter weight conduit that is suitable for use in concealed locations. Flexible metal conduit is used to provide flexibility in wiring systems, such as when connecting to motors or other equipment that vibrates. Non-metallic conduit is a cost-effective option for residential applications, but it must be protected from physical damage. In addition to these conduit-based wiring methods, the NEC also allows the use of cable assemblies for certain applications. Cable assemblies consist of multiple conductors enclosed in a common sheath. Common types of cable assemblies include NMB cable, MC cable, and AC cable. NMB cable, as previously mentioned, is commonly used for residential wiring, but it must be protected from physical damage and fire. NC cable, or metal-clad cable, consists of conductors enclosed in a flexible metal sheath. It provides a higher level of protection than NMB cable and can be used in exposed or concealed locations. AC cable, or armored cable, is similar to MC cable, but it has a layer of paper or other insulation between the conductors and the metal sheath. When selecting a wiring method for smoke detector installations, it is important to consider the following factors. Firstly, the level of protection required. Secondly, the installation environment. Thirdly, the cost. The level of protection required will depend on the potential hazards in the installation environment. For example, if the wiring is exposed to physical damage or fire, a more robust wiring method such as rigid metal conduit or MC cable may be necessary. The installation environment will also influence the choice of wiring method. For example, if the wiring is concealed behind walls or ceilings, a lighter weight wiring method such as electrical metallic tubing or NMB cable may be suitable. Cost is another important consideration. Rigid metal conduit and MC cable are generally more expensive than electrical metallic tubing and NMB cable. It is important to balance the level of protection required with the cost of the wiring method. In addition to selecting the appropriate wiring method, it is also important to install the wiring correctly. The NEC provides detailed requirements for the installation of each wiring method. These requirements cover topics such as support spacing, bending radius, and termination methods. Following these requirements is essential for ensuring the safety and reliability of the electrical system. One of the most important aspects of wiring installation is proper termination. Conductors must be properly terminated to ensure a secure and reliable connection. A proper termination can lead to loose connections, overheating, and even electrical fires. The NEC requires the use of approved connectors and termination methods for each wiring method. Connectors must be properly sized for the conductors being terminated and must be installed according to the manufacturer's instructions. Another important aspect of wiring installation is proper support. Wiring must be properly supported to prevent it from sagging or rubbing against other objects. The NEC provides requirements for support spacing for each wiring method. Support spacing will vary depending on the type of wiring and the installation environment. In addition to these general requirements, the NEC also includes specific requirements for wiring in hazardous locations. Hazardous locations are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dusts. Wiring in hazardous locations must be installed in accordance with the NEC requirements for hazardous locations. These requirements are designed to prevent ignition of flammable materials in the event of an electrical fault. In summary, the NEC provides comprehensive requirements for the selection and installation of electrical wiring. Following these requirements is essential for ensuring the safety and reliability of electrical systems. When installing wiring for smoke detectors, it is important to pay close attention to the NEC fire resistance requirements and to select a wiring method that provides adequate protection against fire damage. Always consult with a qualified electrician to ensure that the installation meets all applicable codes and standards. The NEC guidance extends beyond just the types of wiring and their installation. It also delves into the specifics of circuit design and protection for fire alarm systems, including smoke detectors. Article 760, which is referenced in the initial discussion, focuses specifically on fire alarm systems, and understanding its key provisions is vital for ensuring the proper functioning of these life safety systems. One crucial aspect is the concept of power-limited and non-power-limited circuits. Power-limited circuits are designed to limit the amount of energy that can be delivered to the fire alarm system, thereby reducing the risk of ignition in the event of a fault. Non-power-limited circuits, on the other hand, do not have these limitations and require more robust wiring methods and overcurrent protection. The choice between power-limited and non-power-limited circuits depends on the specific application and the requirements of the local codes. Another important consideration is the type of signaling used in the fire alarm system. Some systems use conventional wiring, where each detector and alarm device is connected to the control panel with individual wires. Other systems use addressable wiring, where each device has a unique address and communicates with the control panel over a shared wire. Addressable systems offer several advantages over conventional systems, including the ability to pinpoint the location of a fire and to monitor the status of individual devices. The NEC also addresses the issue of circuit supervision. Circuit supervision is the process of monitoring the fire alarm wiring for faults such as open circuits or short circuits. If a fault is detected, the control panel will activate an alarm signal alerting occupants to the problem. Circuit supervision is essential for ensuring that the fire alarm system is always ready to respond in the event of a fire. In addition to these technical requirements, the NEC also includes provisions for the documentation and testing of fire alarm systems. Proper documentation is essential for ensuring that the system is properly maintained and that it can be easily repaired if necessary. Testing is required to verify that the system is functioning correctly and that all devices are operating as intended. The NEC also addresses the issue of emergency power for fire alarm systems. Fire alarm systems must be equipped with a backup power source, such as a battery or generator, to ensure that they continue to operate even if the normal power supply is interrupted. The backup power source must be capable of powering the system for a specified period of time, typically 24 hours. The NEC requirements for fire alarm systems are complex and comprehensive. Understanding these requirements is essential for anyone involved in the design, installation, or maintenance of fire alarm systems. Always consult with a qualified electrician and fire alarm technician to ensure that the system meets all applicable codes and standards. Remember that local codes may have additional or more stringent requirements, so it is important to check with local authorities to ensure compliance. Furthermore, the information provided earlier highlights the importance of using fire-rated boxes for electrical connections in fire alarm systems. Fire-rated boxes are designed to contain a fire and prevent it from spreading to other parts of the building. They are typically made of metal or other fire-resistant materials and are tested to meet specific fire resistance standards. When selecting fire-rated boxes, it is important to choose boxes that are listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or Intertech. The listing and labeling indicate that the boxes have been tested and meet the applicable fire resistance standards. Fire-rated boxes should be used for all electrical connections in fire alarm systems, including connections to smoke detectors, alarm devices, and control panels. The boxes should be properly installed and sealed to prevent the passage of fire and smoke. In addition to fire-rated boxes, it is also important to use fire-resistant wiring methods for fire alarm systems. Fire-resistant wiring methods are designed to withstand high temperatures and prevent spread of fire. Common types of fire-resistant wiring methods include metal conduit, mineral insulated cable, and fire-rated cable. Metal conduit is a rigid or flexible metal tubing that is used to protect electrical wiring. It provides a high level of protection against fire and physical damage. Mineral insulated cable consists of copper conductors insulated with a mineral compound and enclosed in a copper sheath. It is highly fire resistant and can withstand temperatures up to 1832 degrees Fahrenheit. Fire-rated cable is a specially designed cable that is tested to meet specific fire resistance standards. It is typically used for fire alarm circuits and other critical applications. When selecting fire-resistant wiring methods, it is important to choose methods that are listed and labeled by a recognized testing laboratory. The listing and labeling indicate that the wiring methods have been tested and meet the applicable fire resistance standards. Fire-resistant wiring methods should be used for all fire alarm circuits, including circuits to smoke detectors, alarm devices, and control panels. The wiring should be properly installed and supported to prevent it from sagging or rubbing against other objects. In addition to these specific requirements for fire alarm systems, the NEC also includes general requirements for electrical safety that apply to all electrical installations. These requirements cover topics such as grounding, overcurrent protection, and wiring methods. Following these requirements is essential for preventing electrical shocks, fires, and other hazards. Grounding is the process of connecting electrical equipment to the earth to provide a path for fault current to flow. Grounding helps to prevent electrical shocks and reduces the risk of electrical fires. The NEC requires that all electrical equipment be properly grounded. Overcurrent protection is the process of protecting electrical circuits from overloads and short circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current if it exceeds a safe level. The NEC requires that all electrical circuits be protected by overcurrent protection devices. Wiring methods are the techniques used to install electrical wiring. The NEC specifies the types of wiring methods that are permitted for different applications. It also provides requirements for the installation of these wiring methods. Following the NEC requirements for electrical safety is essential for protecting people and property from electrical hazards. Always consult with a qualified electrician to ensure that all electrical installations meet the applicable codes and standards. The complexity of electrical codes and standards necessitates a thorough understanding of not just the specific rules, but also the underlying principles that guide them. The NEC, in particular, is not merely a list of do's and don'ts. It's a comprehensive framework designed to ensure electrical safety in a wide range of situations. One key principle is that of redundancy. Many of the NEC requirements are designed to provide multiple layers of protection, so that if one safety measure fails, others will still be in place to prevent harm. For example, the requirement for both grounding and overcurrent protection provides two independent ways to prevent electrical shocks and fires. Another important principle is that of standardization. The NEC promotes the use of standardized wiring methods, components, and installation practices. This makes it easier to ensure that electrical systems are installed correctly and that they are compatible with other electrical systems. Standardization also simplifies maintenance and repair, as electricians are familiar with the standardized components and practices. The NEC also emphasizes the importance of proper planning and design. Before any electrical work is performed, it's essential to develop a detailed plan that takes into account the specific requirements of the installation. This plan should include information on the wiring methods to be used, the location of electrical equipment, and the overcurrent protection devices to be installed. Proper planning and design can help to prevent errors and ensure that the electrical system meets all applicable codes and standards. In addition to these general principles, the NEC also includes specific requirements for different types of electrical installations. For example, there are separate requirements for residential, commercial, and industrial installations. There are also separate requirements for different types of equipment, such as motors, transformers, and lighting fixtures. Understanding these specific requirements is essential for ensuring that electrical installations are safe and compliant. The NEC is constantly evolving to keep pace with new technologies and changing safety concerns. The NEC is updated every 3 years, and it's important for electricians and other electrical professionals to stay up to date on the latest changes. Staying informed about the NEC can help to ensure that electrical installations are safe, compliant, and efficient. In summary, the NEC is a complex and comprehensive document that sets the standard for electrical safety in the United States. Understanding the NEC principles and requirements is essential for anyone involved in the design, installation, or maintenance of electrical systems. By following the NEC, you can help to protect people and property from electrical hazards. The role of local jurisdictions in adopting and enforcing the NEC is also crucial. While the NEC provides a national standard, it is up to individual states, counties, and cities to adopt the code and implement its provisions. In some cases, local jurisdictions may adopt the NEC as is, while in other cases they may make amendments to the code to address specific local needs or concerns. It is important for electricians and other electrical professionals to be aware of the local codes and regulations that apply in their area. Local codes may be more stringent than the NEC in some cases, and it is essential to comply with all applicable requirements. Local jurisdictions also play a key role in enforcing the NEC. Building inspectors and other code officials are responsible for inspecting electrical installations to ensure that they meet the requirements of the code. They may also investigate complaints about electrical hazards and take enforcement actions against those who violate the code. The effectiveness of the NEC depends in large part on the commitment of local jurisdictions to adopt and enforce the code. When local jurisdictions actively enforce the NEC, it helps to create a safer electrical environment for everyone. In addition to the NEC, there are other standards and regulations that may apply to electrical installations. For example, the National Fire Protection Association, NFPA, develops a wide range of standards related to fire safety, including standards for fire alarm systems, sprinkler systems, and emergency lighting. The Occupational Safety and Health Administration, OSHA, also has regulations related to electrical safety in the workplace. It is important for electricians and other electrical professionals to be aware of all applicable standards and regulations. Complying with these standards and regulations can help to ensure that electrical installations are safe and that they meet the requirements of all relevant authorities. The continuous improvement of electrical safety requires a collaborative effort from all stakeholders, including code developers, manufacturers, installers, and enforcers. By working together, we can create a safer electrical environment for everyone.